So, one, thank you.
Hey, pleasure to meet you.
Yeah,
Happy
it's
to
a
be
pleasure
here.
meet you. So the first thing that we're curious about is what inspired you to start Hempitecture, and how has your mission evolved as the sustainable building sector has matured over the years?
Yeah, the story of Hempitecture really begins during my time as an undergraduate architecture student. Fully was anticipating on becoming an architect and designing homes, buildings, whatever it may be. But in that process, I started to learn about the issue with the built environment. And that issue is that buildings and their operations are responsible for about 40% of our domestic carbon emissions. I asked, why is that? And realized that before we invented modern ways of doing things, we built with the earth. We utilized local resources. I looked at what different countries across the world were doing, building with clay, building with straw, building with stone, in some case building with minerals like lime. And I thought, wow, what an incredible opportunity for today. And so I started to look into how could we bring this to the United States in a scalable format. I was really interested in the idea of rapidly renewable plants to create building materials. So in other parts of the world, you have a lot of use of jute or coir or flax. But in the United States, industrial hemp, in my mind, posed a great opportunity because it could be grown regionally, from Florida to Idaho, where I live. And of course, there's some caveats and challenges to the genetics that are required for those different latitudes, but nonetheless, a scalable opportunity for the United States. So the initial concept of Hempitecture was how do we utilize rapidly renewable resources like industrial hemp to create high-performing, low-impact building materials. This concept really was at the core of Hempitecture. I stood on stage in 2013 at my college's pitch competition, and I said, hemp building materials are going to be the future. I was completely laughed at, and of course this was because it was also 5 years before industrial hemp was made federally legal in 2018. People said, you're trying to build houses out of a Schedule I substance. How could this even be remotely feasible? And my belief was, this is going to be an industry that emerges. The legislation around industrial hemp is going to change. I want to be on the forefront of this industry. So the concept of Hempitecture, as it started in 2013, is really still the same as it is today in 2025. Although the business has fundamentally changed, that core premise of utilizing a rapidly renewable resource to create high-performing carbon-negative materials, that's the core of what we do. Today, Hempitecture is a manufacturing business, and our goal and intent is to produce one-to-one replacement materials for the built environment.
So to that point, if I can ask you a follow-up to that. So I go back to 1992. My first papers on psychoactive cannabis found my way to hemp. At one point in one of the iterations of my life, I actually was a general contractor. And so I'm, as a general contractor who is also a person who knows hemp, my curiosity with the product is how does it work as a replacement for the pink stuff? Because you are using it's a matting, it's a non-woven that's being set up like that. What are the comparative R values? How does it hold up over time with gravity sitting inside? Like these are the performance specifications. Because I was looking at it as where does this fit in to be able to? Is it disrupting the market? Is it a replacement in the market? Is it something that is just who is the market?
Yeah.
Right? And what? How does it? What do I have to, as a homeowner or a general contractor, take into consideration with things that it does or doesn't do in comparison? Like how does that? What are those ratios? Where does it come across? So
you're absolutely asking the right questions, and I can tell that you have that lens of a general contractor, because if it doesn't work for the contractor, it's not going to work for a project. Really our focus at Hempitecture is how do we make these one-to-one substitutions as easy as possible, take the itchy pink fiberglass out, put our bat product in. We do think that our product does have the potential to be disruptive in the marketplace, because there is no more carbon capturing material at this performance level in the market. So we think it does have the opportunity to displace things like fiberglass and mineral wool. But in full transparency, it's a long road to get there. to match the price parity of these incumbent legacy materials, it's going to take time and scale.
Let's take price out of it. All right. Let's say you're looking at a person who has the means to switch over to it. Longevity, pest tolerance, fire retardants. And so looking at it from a purely engineering standpoint, because those are you can overcome cost, right? You find a market share that will do it. Where am I going to be in parity to R19 or R28? In terms of how many inches do I have to in the comparison? Where am I at in inches, and then what happens if mice chew through an exterior wall? Where they make a nest out of it? What happens with pests?
For sure. So in terms of the performance characteristics of our product, on a R-value basis, they're very comparable to what you'd see in the market today for fiberglass. R3.69, R3.7 for our bat insulation. Our board insulation is about R3.5 per inch. So these are pretty comparable to what you could see in the market today. Now, natural fibers, they have incredible qualities and characteristics that you're not really going to see or get from materials like glass or mineral fiber. One of the most powerful attributes is the ability to handle, tolerate, and buffer moisture. Moisture plays a big role in how we experience comfort. And so our material will help hold on to moisture and release it while maintaining a high vapor permeability, while also not breaking down. If you compare fiberglass to hemp wool in a split wall assembly, replicating real-world conditions, it's colder at night, it's hotter during the day, there's temperature and humidity fluctuations. Our product, it outperforms these products.
How's it do with black mold?
With black mold, first you always want to make sure that you have the proper detailing considerations to ensure that water is not getting into a cavity, because just about any material will mold. Fiberglass, oftentimes you pull that pink fiberglass out, it's no longer so pink, it's usually a bit blacker. We fortify our products to inhibit mold growth with a bio-based fire retardant. So it has this sort of dual purpose effect of improving the fire resistance of our product while also improving the antimicrobial activity of the product. But the ability for the product to hold and release moisture helps it be a good mold-resistant material. I think there's a lot of people that say, industrial hemp fiber is great, it's antimicrobial. I think that there are characteristics that lead to an antimicrobial effect. I think it's a misnomer to say that it is inherently antimicrobial.
And I've been doing textiles forever, so I get that. So gravity, which I'd like to come back to that. How, if you look at the old rock wool from back in the day, right? You look at an attic that started with rock wool that was like this, and now it's like this, and it's all flat. How have you tested, and what have you seen, and what are your expectations for this product in terms of the impacts of gravity and being vertical over time, or being in an attic, and just the weight of it? Does it compress under its own weight? Does it maintain that? Does it maintain that puffiness?
That's a really great question, and I actually love this question because it's one of the most, exciting attributes of our products in terms of the bat product offerings that we have. So our product, it is predominantly hemp fiber. In some cases, we blend other natural fibers like byproducts of the cotton industry, but it's all bound together with a functional bonding fiber. That functional bonding fiber is doing two things. It is holding the material together physically, but also it helps the material stay in place in the cavity. We use a specialized fiber that has recovery. So that fiber is helping our product expand and recover back to its original form. So our products are friction fit. You have a 16-inch on center wall. You have 14.5 inches in between studs. Well, our product is actually 15.25 inches. So it's super snug. You have to squeeze it in, you place it in the wall cavity, and it expands back. That helps it from settling or sagging over time, whereas fiberglass usually requires mechanical stapling. Sometimes other materials slump under their own weight. Cellulose is an example of the product that can do that, but our product stays fit and is designed for the useful life of a building, so 50 to 75 years.
Do you have a version, a paper to vapor barrier version? Is there a need for that with this?
there's, in the building world, we always say there's good, better, and best. Best is always to have two-way air and vapor control. So in projects that are seeking really high performance criteria, we do suggest that they put an interior air vapor membrane on the interior. Exterior always have to have a WRB, weather resistant barrier. We do not have a product yet today that laminates a air barrier on the product, but it is something that we're keeping an eye on for the future.
Have you considered strategic partnerships with regional? And this is more of a business development question that just because this is my background where I look at companies now. Have you looked into like regional strategic partnerships with insulation companies to be able to go to where you're targeting markets in particular demographics where affluent people who want to have a green home for the children they're going to raise. So like working in sort of like friend of mine in Montana lives in a LEED certified green neighborhood. Like do you have partnerships like that are coming up or that have occurred, or people looking at your product that way?
Some of the biggest evangelists of our products actually are insulation contractors. And it's for a really simple reason.
They don't get itchy.
They don't get itchy. When they use our product, they say, wow, I just installed this with my bare hands. I'm not experiencing the same discomfort.
Right.
And granted, they build an incredible immunity, and I have great respect for insulation installers who are really put on the front lines of dealing with some nasty products, from fiberglass, mineral wool, spray foam, harsh, abrasive, and relatively toxic materials. So we have customers who have an insulation installer install the product. They often say, I would love to use this again. And so they have another project that comes up. They're actually bringing our product
and they're showing
to the customer. They're showing it to the customer.
That's awesome.
That's a great strategy to keep in mind for the future, to develop more of a formalized network of distributors as well as insulation installers. We've done some work to that end, working with a company that has a franchise model for insulation, and they've had a few installations of our product in a number of homes across different regions.
And then just to circle back to the question from earlier, how does it hold up with pests? Do you have any data on that yet? Seeing like mice gets into a wall. I mean, it's natural, right? I mean, they love the pink stuff. What is that? How does it hold up under that? Which isn't an ideal situation. This isn't. I'm not trying to do a gotcha or anything with this. I'm just having seen what happens to the pink stuff or other forms of insulation when pests get a hold of it. There's a part of me that goes, what happens to this natural fiber, which is like a perfect nest when they get into it? Is there anything you've set up to be able to deter that?
Yeah, so that's a great question on pests, rodents. Our products, the fibers themselves, are fortified for resiliency against pests, termites, mold, as well as fire resistance. We have not found any issues with pests, rodents.
That's awesome.
There's some discussion on the silica content of hemp fiber. I'm not sure I completely buy that, but often people say that contributes to sort of a anti-rodent, anti-insecticide
There's definitely a wonder plant narrative that everybody tries, and I
and we try and shy away from that narrative. We make products using a natural resource, and natural resources are great, but there's ways that you have to improve natural resources. We're not just taking a hemp stalk from the field and turning it into insulation. It's undergoing a really rigorous process before it's turned into a product that hits the market. And part of that process, that's our secret sauce. That's what makes our business special. That's what allows us to make these high-performing materials. But we're also in a market that's maybe new in the United States. There's tremendous precedent for bio-based insulation internationally.
Oh yeah, I've seen the
companies
Scottish
like France,
stuff.
Belgium, the Netherlands, UK.
Yes.
They've been using hemp-based materials and other natural fibers for a really long time. So it's very new to us here. From all my research and understanding of working with the companies that we've worked with overseas, these really aren't issues, and they're actually in more challenging climates. Particularly in the UK, hemp does phenomenal. Hemp insulation does phenomenal. It rains more days than it's sunny there. So I think a really great case study for just how these products can do in more extreme environments.
That's awesome. Thanks for your time.
Hey, thanks so much for
I
having
really
me.
appreciate it.
Yeah, likewise.
Thank you.